Okay, so let's start talking about what I mean by moving frames. If you just came from the previous slide set, you've seen this recently, but our ultimate goal, remember, is we're trying to figure out, if I know a point in one coordinate system, how can I transfer that into a different coordinate system? And where we are right now with this is we're just learning about moving the frames. Eventually, we'll understand the relationship between frame transformation and point transformation. And finally, we'll do some work on some more complex examples. So to start, I've got two coordinate frames. I have the world coordinates with x, y, and z, and you can check with your hands to see if you point your fingers along x and curl them towards y. Your thumb points in the direction of z. I'm just trying this now. It works. So it's a right-handed coordinate system. So these are my world coordinates. And over here I have, let's say, robot coordinates because they have the subscript r, and I like talking about robots. And the axes are aligned, right? The y-axis is the same axis. The z-axes are parallel. The x-axes are parallel. And the y-axis just kind of differs by where the origin is, right? So the origin differs by 3 generic units along the y-axis. So a pretty easy question is, what could I do? I think I just answered it in the previous slide. What could I do to the W coordinate frame so that it would align with the R coordinate frame, right? And I want to do it using world coordinates as a reference because that's what I said in my question. And as you've no doubt figured out, that means that I need to translate the world frame 3 units in its y direction. So positive 3 in y sub world, y sub w's direction. So we're going to be moving 3 units that way. So the rest of this lecture, we're going to talk about one subpart of this step 1, right? Step 1 says we're going to learn about transforming frames from one position to another for simple problems. And we're talking about the simplest, which is a transformation that just includes translation and no rotation. So back to where we were, we had said in English, translate the W frame, the world coordinate frame, 3 units in the direction of W's y-axis. And our shorthand for translate 3 units in the y direction is just going to be, we're going to write something like this, translate 0, 3, 0. Okay, and we'll write trans here. We're going to call this process of aligning frames a frame transformation. And we'll use this notation to mean the frame transformation that goes from W to R. So we're always going to write a capital F here and from W to R, which is the frame transformation that moves frame W into alignment with frame R. So we're moving frame W. We start with from W down here. And we always use this capital F to refer to frame transformation. Now, super important, this is not standard terminology. It will make it easier for us to learn. I've taught this for a while now, and I've figured out, I think, pretty well the process that can help people figure out how to do this. But this is terminology that I have written, right? I talk about the frame transformation from W to R, and this F notation is my notation. This is not notation you're going to find anywhere else. On the other hand, if you bear with me and agree that you're willing to use my notation, then we can talk about FWR is equal to trans of 0, 3, 0 for this particular problem. And just to be very clear on which notation is mine and which is not, this using trans with the X, Y, and Z to represent a translation is absolutely common. This is not something that I've made up. On the other hand, this capital F from W to R, that's Dr. K's notation. So that's something that other people may not be familiar with. Okay, so let's turn things around a little bit. Right before I moved from W to R, now I want to align the R coordinate frame or move the R coordinate frame so that it aligns with the W coordinate frame, right? So now we're taking the R coordinate frame and we're sliding it this way. And I think the answer is pretty straightforward, right? We need to take the R coordinate frame and translate it 3 units in that direction. I know because I said up there. And that direction happens to be the negative y direction relative to the robot coordinate frame. So I'm going to say that I need to translate the R frame negative 3 units in the direction of R's y-axis. And of course, we can write this using the standard notation where we're saying we're making a translation only, where x 0 in the x direction, negative 3 in the y direction, and 0 in the z direction. And that lets us do a frame transformation that transforms robot frame into the world frame. So here's a slightly different problem. Again, the important thing to notice here is there's no rotation going on here, right? So y always points up, z always points out of the screen towards you if you're looking at this video, x always points to the right, but the axes are not aligned, and it looks like the s-axis is 1 unit higher vertically than the t-axis, and the t-axis is 5 units to the right of the s-axis. So the problem is asking us, what is f from s to t? How do I transform the s-axis so that it aligns with the t-axis? And it looks to me like I'm going to have to go kind of like that, right? And what is that movement that I've done? Well, it looks like the movement that I've done is a movement of 1 unit along S's, negative 1. So we're moving negative 1 in the y direction, and we're moving 5 units in the x direction, right? So maybe it's useful noticing that, writing that this is the x and this is the y. So when we write our trans statement, we're going to say we're trans 5 in the x, negative 1 in the y, and then 0 in the z direction, because the in out of the paper direction, because of the way I've drawn this, it indicates that the z axes, that both of these actually lie right flat on the screen. So this is just a summary that to get from frame S and to move it so it's aligned with frame T, I need to translate first 5 units. I need to translate this frame, the S frame, 5 units in the X direction, and then negative 1 unit in the Y direction, and that would put me smack on top of this guy with 0 in the Z direction. So of course, whenever I have a couple of axes already drawn, I'm not gonna stop until I've done it the other way. So now I'm asking you, well, how would I take this T axis and move it so that it was in alignment with the S axis, right? What is the frame transformation from T to S? How do I transform frame T so it aligns with frame S? And if we look at this and we say, well, what do we have to do? Again, it's only a translation. We're just moving, we're not rotating. And the X direction looks like this piece, right? So that piece is negative 5 units along the X direction, and we need to go 1 unit up in the positive Y and still 0 in the Z. And here it is written all beautiful like. Okay, last pair of axes for this slide set. Now I've tried to show you how these two axes, these two coordinate frames differ along all 3 of the axes. So they differ in the up-down direction, they differ in the left-right direction, and this is the in-out direction, right? So because of our conventions, we can say that it looks like the C coordinate frame is behind the M coordinate frame relative to us looking at it on our screen. So what are we asking for? We want to know what is F. How do I move the M coordinate frame? So that's this one, so that it's in alignment with the C coordinate frame. And because we know we're going to have to write it in XYZ order eventually, let's just think about it in terms of XYZ order. So here's my XM axis, and I need to move -5 units along that, right? So I'm going to move -5 units, so that's trans -5. My y-axis is the right-left, so that's this next guy. So that's 4 units in the positive y direction, and z is, how much is that? 1 unit in the positive z direction. So here's the slide with the answer on it. And like I said, I can't bear having drawn one of these drawings, especially one as beautiful as this, and not done it the other way. So now let's try and figure out, how do I get the C coordinate frame? How do I move that so that it would be in alignment with M coordinates, right? From C to M. So I've got C, and this is the x-axis of C, right? So I got to do that direction first, which is, looks like it's going to be +5 units. Let me get my pen. So I'm going to do a trans, oops, sorry. And I'm going to go 5 units in the x direction. So we've done that part. And I need to do, which is my y direction. Y is left to right, so that's this guy. And it looks like it's in the negative y direction for the C frame, so that'll be -4. And z is 1, but in this case it's going to be -1 because the c-axis, if you take a look at it, to transform that into the m, I need, sorry, not the c-axis, the c-coordinate frame, I need to drag this frame down by 1 unit, right? And by dragging it down by 1 unit, I am moving in the negative z direction relative to c coordinates. So I'm going to say -1 there. Which is what I have on my final slide. Woohoo!